Hey dear programmers, how are you doing today? Welcome to the channel, and topic of this video is understanding the merge sort algorithm. So I'm gonna do it in a totally different way. I'm not gonna write code, but I'll let you know how things work because I seriously believe that you should understand the algorithm rather than mugging up the code, because your code may go wrong if you don't properly understand what the algorithm does. And if I go ahead and start writing code, you'll try to mug up the code or just remember the code. So that's the reason I'm not gonna write code. I'll let you know how things work, and I will also give you a hint of how to write it in a pseudocode. And once you are aware of how the algorithm work, you can write it in any language of your choice. So for this particular video, I am using this particular array as an example, where I will use the merge sort algorithm to sort this particular array, and I'll let you know step by step how things work. So I have this array with 10 elements. First thing what I did is that I divide it into the smallest possible parts, which is the single elements. Now instead of treating this array as a combination of elements, I keep on dividing it till I get into every individual elements. And this is the reason why we use recursive framework in coding. It's not necessary to be recursive to break things into individual elements. You can very well extract things one by one. But recursion helps while combining it back. That's the reason recursion is there in the coding, and recursion is only meant for programming convenience. It is not part of algorithm, it is programming convenience. So now I have divided it one by one. Let's see what I'm gonna do next. So now I'll combine this first two and create a separate array with two elements and arrange this in a sorted order. So what I will do in step 2 is I come here and I create an array with the capacity of two elements and then compare 1 and 10. So 1 will come here, 10 will go there. Okay. Similarly, I'll do the same thing for this and this. Okay. As well as for this and this one, as well as for this and this one, as well as for this and this one. So let's go ahead. The between 56 and 23, 23 is smaller and 56 is bigger. Okay. Between 34 and 14, 14 is smaller, 34 is bigger. Between 17 and 32, 17 is smaller and 32 is bigger. Between 11 and 21, 11 is smaller, 21 is bigger. So now as part of this step, what I got a sorted array of two elements. So basically when I combine these elements, I made sure that they are in a sorted order. Now after this thing, I will repeat the same thing again with the big arrays. What I will do, I'll combine these two first, then these two, then the resultant with this. So let me go ahead and start with combining these two first. So what will happen over here is that I will take this first element 1, and what I will do is that I'll compare this with both this and this. Then I will go back to the second element, which is 10, and then I'll repeat the same thing again and again. So this is how the algorithm works, that we take the first element of the left array and compare this with the first element of the right array. If this is smaller than this, then this will be used, otherwise this will be kept in this first place, and then this will be compared with the second one, and this process repeats again and again. So let me go ahead and do this for this particular case. So here I am gonna compare these two, 110 and 2356. So even if I replace 110 and 2356 and I reverse the order, the end result will be same. Let's see how. First 110. I took 1 compare with 23. 1 is smaller, I'll take 1. Okay. Then I take the 10 and compare it with 23. 10 is smaller, I take 10. Now I know that these two elements are already in a sorted order. I do not need to compare it again, and I'll just copy it blindly as 23 and 56. Okay. And let me just reverse this order. Let's say I have this one 23, 56 and 110. How the merge sort would have worked in this particular case. So let's take the first element 23. 23 is smaller than 1, no, then 1 will come over here. 23 is smaller than 10, no, then 10 will come over here. Then since 23 is the first element and this comparison is complete, 23 will come over here, and since this is already in a sorted order, next 56 will come over here. So it doesn't matter which sequence you do your comparisons. Okay, so the end result will always be same. Now I got 1, 10, 23, 56 by comparing this. Let me do the same thing by comparing these two also. So now what I have 14. Is 14 less than 17? 14 less than 17? Yes, then 14 will come into picture. Now let's take the second element. Is 34 less than 17? No. Then 17 will come over here. Now is 34 less than 32? No. Then 32 will come over here. Then 34 will come over here. And let me keep this two-dimension array as it is. Okay, for now. Now after that we can do some different things, like we can either combine these two first and then with the resultant I combine with this, or I combine these two first and then the resultant with this. So as I already said, no matter which sequence you use, at the end the result will be same. So let me go ahead with combining these two first and then result will be combined with this. Okay, now let's go to step 4. Now let's see. 1, I have taken first element and comparing with first. Okay, 1 is smaller. Okay, 1 I will take it over here. Now I am taking the second element. Is 10 is smaller than 14? Yes, 10 also gone from the first array. Is 23 smaller than 14? No, then 14 comes over here. Is 23 is smaller than 17? No, then 17 comes over here. Is 23 smaller than 32? Yes, then 23 comes over here. Now I took 56. I know that these two are already part of the array. I will not compare with these two. I am taking 56 and comparing with 32. Is 56 less than 32? No, 32 comes over here. Same comparison with 34? No, 34 comes over here and 56 comes in the last, and this will remain as 11, 22, 21. Okay. Now in step 5, what I will do is that I'll do the same comparison between this and this, and let's see how the result will look like. Now each 1 is smaller than 11? Yes, then 1 will come. 1 is gone. Now I've taken 10. 10 is smaller than 11? Then 10 comes. Now 14. 14 is smaller than 11? No, 11 comes. Is 14 smaller than 21? Yes, 14 comes. Then we took 17. Is 17 smaller than 21? Yes, 17 comes. Is 23 less than 21? No, then 21 will come over here. After that, we know that there is nothing left in compare over here, and this is already in a sorted order. It will just come here as it is. Okay, so this is the way merge sort algorithm works. So let's talk about complexity. While dividing, we touch all the elements, n elements. So we are already touching n. And while combining these two using these steps, we might be touching n, but not necessarily all the time, because as the array grows, we know that second is always in a sorted order and we always compare with the first element. So it turns out to be the logarithmic complexity. So the overall complexity will be n log n. Okay, so n into log n. This is the algorithmic complexity. It is relatively faster algorithm than just bubble sort or linear search sort. Now let's see how the code is generally written. So for the merge sort, you have seen the code. It says that okay, the merge sort, let's say index 0 to mid, and then again merge sort, you do it from mid plus 1 to end, and then you merge the result. This is the code of merge sort. So as I told you in the beginning, this is recursion is done only for programming convenience, because you can very well use this array index to find individual elements. But if you use recursion, once the recursion completes, it gives you the next partner to merge for. So this is the left thing to merge, this is the right thing to merge. So what happens over here is that once you divide it, first time it will divide it between 5, 5. Next time it will divide between 3 and 2. Next time this will be divided between 1 and 2. And next time this will be divided between 1 and 1. That's the way merge sort actually divides them one by one. Okay, so I hope I was able to explain what is merge sort and how it works. If you understand that, try to write it in a code. And for this particular example, try to write merge sort without going into recursive loop. You will understand it in a much better way. Of course, recursive merge sort is the best solution for writing code, but as of now, just try to combine these elements one by one, first in chunk of 2, then in chunk of 4, till you reach the number of elements. You'll be able to understand what exactly is happening, and you will also be able to just calculate number of steps that it takes to come up with this particular result. So thanks a lot guys, thanks for watching. If you did like this video, please let me know. I'll just go ahead and create more algorithmic videos in this particular way, because my intention is to explain you, not to just give you a ready-made solution. Thank you, thanks a lot, thanks for watching. Please do not forget to subscribe and let your friends know about it. Thank you.